Good morning. Thank you for this opportunity to tell you a little bit about the Interdisciplinary Plant Group at the University of Missouri. So I'm Bob Sharp, a professor of plant science, and I've been here for a long time, but recently became director of the IPG, as is known. So the IPG was established about 30 years ago, and it was part of an initiative that the University of Missouri took in early stages of looking forward to trying to solve some of the problems in food security that would be occurring as time progresses. So the university had the insight to establish the Food for the 21st Century program in 1984 to look forward 20 years into the future to address major challenges and constraints that would occur at that time, and had targeted investments in several areas, including plant science, that was very instrumental in the success of the Interdisciplinary Plant Group that was established around the same time. And we're very pleased, obviously, that the result of that investment has been a tremendous success in plant science at MU, and evidenced by our ranking here, shown at the bottom there, that we're ranked 14th in the world for the impact of plant science research among institutions across the globe from this Times Higher Education report. So who is the IPG? So it started from a small group, as I said, established in 1981 to develop a program of excellence in plant science. It has led to the development now of 57 faculty teams, and we're recognized both locally, nationally, and internationally as an interactive research and education community. And I would just like to draw attention to this guy here, Doug Randall, who's in the audience. Doug, raise your hand. Doug was the founding director of the IPG and was really instrumental in establishing the philosophy of the IPG, as I said, as a research and education community that works together to facilitate cooperative plant science research and education on campus. Now, with 57 faculty involved, obviously that incorporates and encompasses a wide range of expertise and interests. But the interests of the group coalesce among these three areas illustrated here: genetic diversity, developmental mechanisms, and abiotic and biotic interactions, under a general umbrella of plants for changing environments. I'd just like to highlight the traditional history of innovation in our work in genetic diversity. This encompasses the two major crops in the state, maize with the Missouri Maize Center and soybean with the National Center for Soybean Biotechnology. I just want to highlight some of the accolades that have been given to past and present plant geneticists at the University of Missouri, going back to Ernie Sears' work, received the Wolf Prize in 1986 for his research in wheat genetics. Ed Cove on the right-hand side here, Thomas Hunt Morgan Medal in 1992 for lifelong contributions to maize genetics. And also point out in the middle on the top row, George Redeye, who came here from Hungary and initiated work with Arabidopsis, which is now the model system used throughout the world as a model genetic system. That work was initiated by George here in 1957. Those accolades continue to our current scientists. James Birchley elected to the National Academy just a couple of years ago. Mike McMullen and Sherry Flint Garcia in the USDA Plant Genetics Unit on campus, who was part of a national maize genetic diversity team that was awarded the USDA Secretary's Honor Award in 2012. And just a couple of weeks ago, Perry Gustafson, who was had a greenhouse complex named in his honor at the University of Nottingham in the UK for his work in advancing global wheat production. Now, what I'd just like to spend a few minutes on is one area of particular emphasis and expertise within the IPG, which is a team is coming together to address a really complex and understudied question. That is root biology and the involvement of roots, particularly in adaptation to drought, but also biotic stress interactions, nematodes, insects, and pathogen interactions. Illustrated on the left-hand side is the example of insect interactions with roots. This is corn rootworm damage from Bruce Hibbert, again in the USDA Genetics Unit on campus, showing devastating effects on the root development that can occur. And as you might expect, effects such as that would have greatly interactive effects with the importance of roots in nutrient and particularly water uptake under drought conditions. And This audience probably needs no introduction from me to indicate that drought is the most important factor limiting crop productivity worldwide, has huge economic effects both in the US and globally. Obviously, therefore, also has major effects on global food security, and the situation is only going to get worse because of the growing world population. So, in that sense, we're very fortunate at the University of Missouri to have considerable expertise both in root biology and in drought research. And this is an unusual combination of expertise, and it's actually unusual to have considerable expertise in root biology because root biology is really one of the most understudied areas of plant science, and I've neglected to point out on the previous slide that it's often referred to as the hidden half. So that's an obvious statement. Roots are underground. It makes them more difficult to study, and they have been studied a lot less than they should do. And it's, but at the same time, they're one of the most important parts of plant biology, and that's particularly true under drought situations. Obviously, roots are the part of the plant that take up water from the soil, and I was pleased to hear in one of the presentations in the previous panel about the importance of rooting depth. And it's an obvious known fact, and it's known there's considerable genetic diversity in the ability of roots to penetrate into the soil and to adapt to a soil drying situation. But the mechanisms involved in this, the fundamental science that is involved in root adaptation to drought is one of the least studied areas, but most important as well. So as I said, we have considerable expertise at the University of Missouri within the IPG that allows us to bring scientists from different disciplines together to work as a team to begin to make more progress on this challenging question. And so we have an IPG drought team that is beginning to address the question shown here, roots under drought and model systems to the field, going from our fundamental strength in plant science across the IPG, drawing on that expertise and working together to begin to address the complexity of root growth and development and adaptation to drought in the field. And I highlight my colleague Felix Ritchie here, who was instrumental in leading an effort to get funding to establish a network of these so-called rainout shelters, effectively greenhouses on railroad tracks that are established now at our agronomy farm that we can use to accurately impose drought conditions and allow us to do more, take our fundamental plant science out to the field. Now our work extends then across the IPG, but that philosophy extends beyond the IPG, and the IPG is a lead partner in a newly developing International Food Security Alliance. This is led by Professor Bill Davies at the, Lancaster University in the UK, and the IPG and MU and China Agricultural Universities are lead partners with several other universities, as shown here, from around the world. It's a fledgling alliance. It's just getting off the ground. We've had 2 meetings so far that were held in Beijing, and the outcome of those meetings are agreed upon research focus on below ground systems, the area that I've talked about today, root biology and the involvement of roots in drought and nutrition, particular focus areas. And, but the IFSA also has developed an educational goal to develop an international PhD program in food and water safety and security that to try to provide students the opportunity for international, greater opportunity for international exposure and involvement as part of their training program. So these would be, if we succeed in this plan, would be joint degree programs offered among the group of participating institutions. From MU, as shown on the left, this doesn't just involve the strengths of plant science in the IPG, but also, just mentioned in the previous talk, FAPRI, the Food and Agricultural Policy Institute, and also the Interdisciplinary Center for Food Security, which is focused on domestic food security issues in Rural Sociology Department. So I'd just like to finish with a slide that tries to summarize the points that I've made. This is a vision, if you like, of the IPG, and I'd like to extend that vision to the International Food Security Alliance. First, I think we need to integrate traditional university research strengths greater and take greater advantage of the knowledge and the strengths that we have in universities. And this was pointed out this morning in one of the talks in the previous panel, that USAID hasn't been as effectively harnessing US university resources as it might. We feel the same way. We have tremendous strengths in plant science at the University of Missouri, but my feeling is that we're not as integrated, that expertise is as integrated as it might be in participation in solving global challenges and working with end user partners to appropriately and collaboratively define what those limitations are and make the best use of existing knowledge through synergistic partnerships that allow us to put that knowledge into play as rapidly as possible. To this end, I've started a program within the IPG to facilitate, to support students, faculty and students who would like to start developing those international connections more than we have at the moment. These by on-the-ground visits to institutions and scientists in developing countries around the world. This is not something that you can happen overnight, and it requires some investment and some time to support those activities. And I'd just like to thank Dr. Ejeda for visiting with our IPG grad students and postdocs yesterday and to discuss international opportunities. They were very excited about that. Number two is to use that existing knowledge in more rapidly translating that knowledge to useful outcomes on the ground. Undoubtedly, we have a lot of existing knowledge that could be go a long way towards solving or towards addressing existing problems. But to reinforce what Mark Leonard said in the previous talk, we also feel that there's a real need for greater investment to enact novel visionary solutions, not just to use existing knowledge, but to gain much greater knowledge to move forward and address and hopefully solve, not just address, current and emerging obstacles. And that requires, if we were to move forward in partnership, take advantage of strategies that span both the fundamental biology that's necessary and field application. And if we work together from the beginning, we can move forward more rapidly towards that goal. The root biology area that I talked about today is one of those, is a great example of that. We know so little about it. We really need to pick up speed on understanding the fundamental biology, but if we do so in communication with end users and address those the particularly most important target questions and start now, maybe we can both catch up, but also make more progress towards getting those problems solved as we move forward. So thank you very much.